Yes, I have an exercise for you. The question will be, what is the covariance of the following population data? You have like 3 points. The point 2.1, 2.1, 3.5 and 4.6. Hey, it's exactly the same data as the last example. Only in the last example it was not the population data, it was sample data. So probably because now you got population data, you will get an other answer. Please, what I put here for you is the formula for the correlation for the population, and I put here, notice, look good, not a formula for the variance of the population, but for the variance of the sample. But we don't need to use this formula. So think, what has to change in this formula? What do you have to change? At first I will just help you with this. It will be the variance of x squared will be 1 divided by n. The minus 1 will disappear. It's a sample correction factor, and instead of the x bar you will use the Greek sign mean. That's all. Please stop the video and then we're gonna continue after you made the exercise. So 5, 4, 3, 2, 1 and stop the video. Welcome back at the video. I'm gonna give you now, I hope you did a good job and you made the exercise like perfect. If not, it doesn't matter at all, we're gonna make it together. First, we need these 3 things. We need the covariance of the population. And we didn't calculate it before, so we have to calculate it now. I will first rewrite the formula. It looks just the same as above, so it's really easy to rewrite it using the formula which is stating there above. Instead of x squared, you have the x times the y, and instead of the mu square, it will be the mu of x in this case. We get the mu x times the mu of y. And now I've rewritten the formula. Now what I can do is just fill in all the numbers. It's easy to put behind the x times y for this part, for the summation of x times y. X times y is in this case 2, in this case 3 times 5 is 15, in this case 4 times 6 is 24. And if you sum them up, you get 4, 9, 11, and you get here 41. So this piece will be 41. 1 divided by n will be 1, 2, 3 couples, so 1 divided by 3. Minus the n would be 3. The average of 2, 3 and 4 will be 3. And the average of 1, 5 and 6 will be 4. Next, I'm going to calculate the variance of x. We need a standard deviation, but first the variance, and we'll take the square root. So 1 divided by 1, 2, 3, n is 3 in this case again, equals, I just write it down with a green color, 1 divided by 3. And you get here the summation of x, so x squared, so 2 squared will be 4, 3 squared will be 9, and 4 squared will be 16. And if you sum them up, you will get 29. So this piece will be 29 minus 3 times 3 squared. You have to do the same exactly with y. So 1 squared becomes 1, 5 squared becomes 25 and becomes 36. So the variance of y will be 1 divided by, again, n, 1, 2, 3 times, if you sum up these 3 numbers, you will get 6 and 6 is 12, 62 minus n will be 3 again, and the average will be 4. I calculate everything on my calculator, and I will get as answers 2/3, 4 2/3, and for the covariance I will get 1 2/3. So to calculate the correlation, it will be 1 2/3 divided by the square root of 2/3 times the square root of 4 2/3. Remember, we just calculate the variance, and the variance is the squared standard deviation, so we have to take the square root to get the standard deviations. And the answer will be 0.945, which will be exactly the same as a sample correlation. So like for covariance, it makes a difference to calculate the covariance for the sample or for the population. For standard deviation, it makes a difference to calculate the standard deviation for the sample or for the population. But for the correlation, in the end it doesn't matter, but for your teacher it's important that you use the right formulas, otherwise you can get like deduction of points. So always do it this way: use the separate formulas for the population, use the separate formulas for the sample. You will get always your full points.